This is going to go ahead and review our work with rational functions. Remember, a rational function is a function whose rule can be written as a ratio of two polynomials. The parent function looks like f of x equals 1 over x. Its graph is a hyperbola, which is two separate branches. So logarithmic and exponential functions, as we already talked about, have asymptotes. The function f of x equals 1 over x has a vertical asymptote at x equals 0 and a horizontal at y is equal to 0. We can write these with a dotted line when we do our graph, and we have to make sure that our two branches do not cross those asymptotes. The rational function can be transformed using methods similar to everything else that we've been doing in this unit. We have a, which stretches or compresses our function, h is the horizontal translation, and k is the vertical translation. Remember, when we did these, we had h was the x value and k was the y value, and we changed the point 0, 0, where the asymptotes cross, to the point hk. So, since h is negative 2, we translated 2 units left, which means that our new asymptotes will be with the center at negative 2, 0. So we have the red one, which is our new vertical asymptote, and the other one is the x-axis, which is not drawn, but it's right across the x-axis at 0. Okay, and we have no stretch because the a on the top is 1, so it'll look exactly the same, just moved over 2 to the left. For the other one over here, we have k equal to negative 3, so we're going to translate it 3 units down. So our original parent graph looks like this. We move our asymptote 3 units down. Remember, the second one is still vertical at 0. And we go ahead and draw our two branches. So try these two on your own and then double check your answers. The first one is going to move 4 units left. So we move 4 units left, redraw our asymptote, and draw our two branches. And for the b, it will move 1 unit up. So we go ahead and move our asymptote up 1, and we keep our vertical in the same place. The values of h and k affect the location of the asymptotes, the domain, and the range of rational functions. So for a rational function with this form, the graph is a hyperbola. There is a vertical asymptote at the line x equal to h, and the domain is x can be anything except for h, because since it's an asymptote, x cannot cross it. You can have anything above or below, but you can't cross it. There's a horizontal asymptote at y equals k, and the range is y can be anything except for k. So let's look at our second example. We want to determine the asymptotes, domain, and range of this function. So we have h is negative 3, k negative 2. Vertical asymptote is at negative 3. Domain is x anything except negative 3. K is negative 2, so the horizontal asymptote is negative 2. And the range is y can be anything but negative 2. So if we go ahead and graph this, we can see that we have our 0, 0 has been transformed left 3 and down 2. We redraw the asymptotes and then draw our hyperbola with one branch at the top and one branch at the bottom. So we have another example here. We identify h and k. Vertical asymptote at 3. Domain is x can be anything but 3. K is negative 5, so y can be anything except for negative 5. And then when we graph it, we can see that it goes to the left, or to the right 3 and down 5. So we redraw our point at 3, negative 5, draw our asymptotes, vertical and horizontal, and draw a branch in the top right and the bottom left.